and I'll turn it over to Jay Barone from Winnie Lyric, who is our presenter for today.
Hi, everybody. Thanks for joining us today for our session on 3D printing for libraries, or as I like to call it, the stuff you should know before you mess up a patron's print. Just a little roadmap of what we'll be covering here. These are the things that we're going to be going over. A little basis of what is 3D printing. I'm going to tell you about some models you'll probably find in libraries. Tell you about setups, benchmarking, where to get your models, all the things that you need to know in order to acquire, set up, and operate a 3D printer, as well as troubleshooting some of the things that may go wrong when you have a printer that isn't behaving right. If we have some time after that, we'll get into some advanced materials and some mods that you can do to make your printers even better. And then we'll also talk about some other types of printers that exist out there. We're going to drop a link in the chat to a Padlet about your experiences for the people on this call, your experience in 3D printing. If you can pop onto there and give me some information. Does your library have a 3D printer in your Makerspace? Are you considering purchasing one? And if you do have one, what kind do you have? If you can pop over there and give me some information, that'll help inform what I talk about. And hopefully everything will be more relevant to those people who already have printers. And then we can branch out to those folks who don't have printers, and we can get you some of the pros and cons. So you're probably asking, who is this guy anyway who's talking to you about 3D printing? My name's Jay Barone. I'm the Technology Services Coordinator here at Winnie Lyric. My contact information, my email, my phone is right here at the top. I've been using printers for about 4-ish years. I started right before lockdown in 2020, really getting into it. I am totally self-taught. And right now, I mostly do high temperature engineering materials, some crazy stuff that we'll talk about at the end. I've gotten to a point where I'm pretty proficient in designing functional objects, things that do things. And my primary focus as a maker, I make watches, I make watch cases, I make prototypes for one-off things that need to interact with other objects. I also really like replacing obsolete mechanical pieces or discontinued components. And after all that, I've had about 15 years of libraries experience. I've been around. So I'm kind of coming at this from not just the hobbyist angle, but also from the librarian angle. And the overall reason that we're here is that 3D printing is becoming more and more common, and makerspaces are becoming more and more common in individual libraries. But 3D printing is really not the sort of thing where you can just buy the equipment and have it magically work. There are tons of little details to be aware of that will affect how your prints work and how they come out. And it's also really, really hard to find training, especially training that is in a library context, unless you really like reading forum posts and diving through message boards in order to solve your own problems as they come out. A lot of us as professionals, we don't really have time to do that, but we need like a basis and a springboard to start from, and those are often very hard to find. And also, in my experience, it has always been easier to acquire money for technology or money for stuff than it is for money for the staff to run the stuff or the training to make sure the staff is able to run it. And what ends up happening is libraries will end up purchasing technology that needs some expertise to run, and they may not necessarily have the expertise or have the time to get that expertise. And that means nobody wins. The 3D printer sits there. Your folks don't know how to use it. Your staff doesn't know how to use it. And this is here to fix that. I want to cover the basics to get you acclimated with your printers and make the information you need to make decisions to purchase and use them. I'm also going to provide you with a bunch of resources so you can learn on your own. A lot of this stuff you have to learn by doing, but I've got some guides for you to kind of get your mind around those. And also, one of the coolest things about 3D printing is it is a huge community of makers, nerds, people that love sharing, learning, growing, and collaborating. And I'm hoping that we can start here and try to build that community in the Western New York Buffalo Library region. of people that know about 3D printers and they know how to use them so that we can all benefit from the knowledge that we as a collective can have. That's a lot of words to say that 3D printing is really hard, and we're here to help you not be terrible at it. So the very basics of how a printer works. This is a general diagram of what you're looking at. You're going to have some sort of material. That material is going to get heated up until it's molten, and then it's going to get squished out in a bunch of layers until you get a model. The dictionary definition of 3D printing is up there at the top, with the action or process of making a physical object from a three-dimensional digital model, typically by laying down many thin layers of a material in succession. It's basically like your regular printer, where the print head will move back and forth, up and down the page, depositing ink or toner where it needs to be to form the individual letters that form the individual words that make up your document. 3D printers do exactly that, except instead of using ink, they use some other material like a plastic. And it has another axis of motion where it can move vertically and put layers on top of the previous layers so that you're actually able to build things in that third dimension. We've got a diagram down here. This is the 6-part process of 3D printing, of going from your model to the files, getting them ready to go, generating your toolpaths, and actually printing it and get your object. That 6-part process can really be boiled down into 3 words: model, slice, print. Every single 3D printer in the world operates on this exact principle. You're going to get a 3D model. You're going to use software to cut that model into a whole bunch of different vertical layers. And then you're going to feed the instructions for those layers into a printer so that it can recreate them one by one in order. And so you go from a 3D representation of an object on your computer to a physical solid object in your hand. All of this process is nothing but modeling, slicing, and printing. So I'm looking at our Padlet information here. For those of you who have library printers, this seems to be confirming my suspicions here. These are the types of printers that you will generally see in libraries. These are what's called FDM printers, fused deposition modeling. You don't need to know what it stands for. Just FDM printers are these kind of printers. These are the ones that use solid plastics as their feedstock. And they have a lot of advantages for libraries. They're often cheaper than other kinds of printers. They can produce larger sized objects because the space available to build on is generally larger. And these can use different types of materials really easily so that you can make functional things or prototypes or decorative objects with different materials depending on what your needs are. Some of their downsides are that they have more moving parts than other types of printers, so figuring out what's wrong can be a little bit harder. The more moving parts you have, the more things there are to go wrong. But the repairs are really not that difficult. Everything uses off-the-shelf, commonly available components. Everything is repairable, and you can buy tons of different models of these, either ready-made, or you can buy them as kits to build your own or to modify your own ones. Now, the process of FDM, as I mentioned, uses a plastic as a stock, which we call filament. The filament's usually sold rolled in spools of about 1 kilogram, and the filaments come in all sorts of different colors and different materials. As far as materials go, the most common two are PLA and PETG. PETG is it's stuff they make plastic bottles out of, but your guys are going to be printing almost exclusively PLA. PLA is a great plastic to work with. It is super easy to print. It is very responsive to your settings. It works really easily in a wide variety of conditions. I would recommend you start with PLA. Everything in here you do with PLA. Once you've figured out how PLA works and you've mastered all the parts, then you can move on to other materials if you want. but you don't have to. You can also, if you get there, you can print in things like ABS, which is impact resistant plastic, or nylon, which is a really strong, slippery plastic for like gears and stuff. Most makerspaces will have one of these for several reasons. It's the easiest process for you to wrap your mind around, but there's tons of different details for you to really get into if you want to explore. I always say if you can only have one printer, buy an FDM printer because it has the widest functionality, it is the easiest to use. And remember, a lot of the impetus behind makerspaces and libraries was to present advanced manufacturing skills to our patrons. FDM printing has the greatest correlation to currently available manufacturing skills. It works a lot like the CNC process. And if you listen to the radio right now, you will hear that CNC machinists are being hired gangbusters. Everybody needs that expertise. And this is an excellent place to start learning the thought process that you need to know to get into a lot of advanced manufacturing. So I mentioned all these are pretty much the same. Depending on your brand, they may look different, but every FDM printer has the same basic set of components that make it work. The first thing they have is this square frame around them, which is called the gantry, and that just provides a place for the other components to get bolted to. In front of the gantry, this little guy with the warning on it, that is the extruder or the hot end. That gets hot, melts your plastic, and pushes it out so you can make your model. That thing moves, and it moves in two directions or two axes. It moves back and forth to the left and the right of this picture, and that's across the x-axis. And also this entire carriage that it's attached to can move up and down on the gantry, and that's called your z-axis, up and down. The third axis of motion, which is your y-axis, which is in and out of the plane of this photograph, that is provided by your bed or your build plate. It's the same thing, just different terms for it. That gets heated up and provides a place for your model to stick to, and it also moves back and forth to give you that other direction of movement. Attached to the extruder is this little tiny guy right at the end of the arrow. That's the nozzle. That is where your plastic will be pushed out of, and that nozzle is pretty important for some later steps that we're going to cover. Below the nozzle, we have the filament spool holder. Your filament will go on there, and it'll be threaded through this little white tube that you can see up at the top. It's called a Bowden tube. That just keeps your filament from getting snagged in all the other wires and stuff and make sure your print keeps going. Finally, the last thing at the bottom is the screen. That's how you interact with the printer. That's how you select its settings and things like that. Every printer, regardless of brand, will have these same parts or their exact analogs. And some of our common brands that you'll see, the most common one I tend to see are Creality, which makes the Ender series. Those are very, very common. They're very cheap. They're really easy to modify if you want. And there are tons and tons of people who use them. Their downside is the documentation isn't great. And sometimes their quality control is a little dodgy. But these are fantastically cheap on sale. Even in their like regular confirmation, they're not that expensive. These things top out at $300–400, as compared to a Prusa, which I see somebody in here currently has. That orange printer there, that is a Prusa. Those are fantastic. If you have the money, buy a Prusa. It will make your life so much easier. There's a bunch of different features that it has that will, it's the closest thing to press button receive print that exists in the 3D printing world. These are fantastic. I don't have one of these at home, but I have one here at work. I absolutely love it, but they are pricey. They start at about $700 up to $1,000 for pre-built ones. So they may be out of your budget, but there's a reason you're paying for that. Excuse me. Finally, there's Anycubic. They're kind of a second generation Creality. They took a bunch of Creality's designs, they ripped them off, they put on some nicer components, and they bumped the price a little bit. They're pretty much the same as Crealities with a little nicer features. They have a lot better support, but not as many people use them. However, all of these printers are pretty much the same. They operate on the same principles. A solution for a Creality is going to work on an Anycubic and a Prusa. It's all the same process. But after going through all the brands, because there's several more that you could get, the most common question that I'm asked is, which is the best printer? And there's a really, really easy answer for that. The best printer is the one that you have. If you take the time to know your machine, if you know how it works, if you take the time to just observe its little foibles, every machine is going to work slightly differently. If you know your machine, then your prints will come out better than they will on any machine that you don't have. It seems really simple, but it's true. Printers have different features and they're priced at different levels, but the best printer is the one that you can use. Does not matter what brand it is or kind. It is the one that you have and you spend the time to use. So you got your brands, you've thought about what you're going to purchase, you've made your decision, you've gotten all your purchasing stuff done, and now you've got your object, and all right, I'm preparing for my first print. What do I do? Your first print might come out looking like the one on the left here, but it might come out or looking like the one on the right here, but it might come out looking like the one on the left. That's just sort of how it goes. The reason I picked this particular image is because this little boat is going to become very familiar to you. I want you guys to meet Benchy. Setting up a printer is really, really difficult. It's really fiddly. And Benchy is a model of a tiny little boat that's been created so that you can calibrate and adjust your printer in a ton of different ways just by printing out a Benchy. It is a bunch of different features that are designed to test the parameters of your printer and how well it works. And it's kind of 3D printing tradition that the first thing you print on any new printer or the first thing you print with any new filament is going to be a Benchy. The exact analysis of a Benchy is kind of a detailed process. So I've got a link here that's going to be dropped in the chat for you. And it'll also be available on these slides for how to analyze a Benchy. Once it's been printed, how to check to make sure that everything is working right. And then below that, there's also a link to the official site for 3D Benchy. It is so popular that it has its own site. It's been downloaded 2 million times off of their site alone. And there's a lot of information that you can get about Benchy on there. And that also includes how to analyze it, all sorts of different resources. The most important thing when setting up for your print is keeping your bed level, because the filament needs to come out of your nozzle and then is deposited on your plate and needs to stick there. The relationship between where your plate is and where your nozzle is really important. And there's several things that you can do that you can tell immediately whether your bed leveling is good or not. In this lower image, there aren't that many pixels in here, but you can still kind of see. Over on the left, that's when it's too high. The filament is not sticking to the plate, it's sticking to itself. And so you get areas that are really patchy, and then you get areas that are really thick. Over on the right, that's what happens when the nozzle is too low. There's not enough space for your plastic to come out and stick, and it just scrapes off the plate. So you will see nothing sticking there. In the middle, that's what it looks like when it's perfect. And this, making sure your bed is level, is going to be the most important thing that you do when you interact with your printer to make sure it works. Excuse me again. Unless you have a Prusa, you're going to spend a lot of time doing this. And this is pretty much the fact that Prusas do this automatically is almost the entire reason that you're paying for the premium for those. So most printers are going to have a setting to level your bed. And what that's going to do is it's going to move your nozzle to sit over the corners of your plate. And you're going to measure how far away the nozzle is from that plate using a piece of paper. The guideline is that your piece of paper should be able to move freely between your nozzle and your bed, but you should be able to feel the nozzle scraping. And you want to make sure that you go around your bed at each corner a couple times and check to make sure that it is about consistent and it's about at that level of pressure. This is something that there really is no way to learn except to do. And you will spend a lot of time doing it. But once you get the hang of the feel of it, it's really easy. There is a guide here that I've linked. We'll drop that in the chat as well. And that is an entire web page on how to level your bed step by step for different printers. And how to make sure that everything is perfect. And that'll give you what you need to get started with playing with this. One caveat with this, if you guys remember back to your middle school science classes, things will expand and contract when they change temperature. And given that this process needs heat to work, that means that your nozzle and your bed, which are the two important parts, are going to be hot when you're printing. And that means that they're going to be a slightly different size and shape than they would be when they're cold. So make sure when you level that your bed and your nozzle are preheated. I learned that one out of experience, just screwing up. Why can't my bed level? Until I realized that it was changing shape slightly when it was heated as compared to when it was cold. And so my leveling when it was cold didn't matter. So you've leveled your bed, you've got your everything set up, your printer is ready to go. The only model you have is a Benchy. You probably want some more things. The next step in the process is acquiring models. And this is really, really easy because there are thousands and thousands and thousands and thousands of models that are already available for free or for a small charge out there on the internet. If you need something or you want something, there's probably a 90% chance that somebody has already made it and put it out there on the internet. Some of my favorite sources on here are listed. That first one is Printables. Printables is relatively new. It's the Prusa's site for models, but those can be printed on any printer. It has a great search, great interface. All the models are free. They have some really cool giveaways and design contests that they do. You can always look there. Below that is Thingiverse. Thingiverse is kind of like the original 3D model site. It's kind of old and the developers have sort of abandoned it, so it doesn't get updates, so the search doesn't work all the time, but there are so many models available on there that it's still really worth checking. One of the ways that you can access models on Thingiverse when their search isn't working is through like a meta search engine, such as thangs.com, Thangs. That searches multiple 3D model sites, including these ones here, but it also searches some other niche sites. A caveat with that is that all 3D model sites have different terms of service governing what is acceptable to put on there. You won't really have a problem on Printables, not really on Thingiverse. There are some other sources where you can get spicier items, things that are probably against your library's terms of service to print. They exist and they may turn up in your search, but just be wary that different 3D model sites have different purposes and different terms of service and host different types of models. I always go to Printables first. It's fantastic, unless I'm looking for something really weird, in which case I'll go to Thangs. If your model does not exist, that's when you're going to model it yourself. And you're going to do that through what's called CAD, or computer-aided design. The place to get started in CAD, I would recommend using this top one, Tinkercad. That's where I was started. It's free. It is online. You can use it in your browser, and it can be very, very, very powerful. And it's kind of meant for beginning users to teach you the workflow. Once you've mastered Tinkercad or gotten into things where you need exact specific dimensions, that's when you're going to move up to something like Fusion 360. Fusion 360 is as close as you get to an industry standard for a CAD program. It is ridiculously expensive, but you can get a hobbyist license to use it. And that's effectively free. And they say it only lasts for a few years, but they will keep you on indefinitely because the more people who know Fusion, the closer to an industry standard it becomes. I believe that link there actually is a link to their hobbyist license, so you should be able to get that easily. And then finally, the last one I recommend is Blender, which isn't technically CAD per se. It's more digital modeling. It is extremely powerful. It is free, but the problem is the learning curve is basically a vertical cliff. It is extremely difficult to do things, and it is very intimidating for first-time users. There's tons of tutorials that are available to get you to learn it. But one thing that I have always had trouble with is that when I use Blender, I lose a sense of scale. So I might spend all my time making an object, and then once it is exported and ready to be printed, I find out that it is like half the size that I think it is, or it's twice the size that I think it is, and then I need to do all this other stuff to make it work. So this is an example of what one of my designs in Fusion looks like. As the red text in the corner says, if you want to learn how to do stuff like this, to model, stay tuned for our part 2 of this webinar, which is going to go in depth into like 3D printing the nerd stuff, and then also how to make models like this. So in the background is my full model. It's all textured. It's really nice and pretty. And then in the front, this little gray shape, that is the exported 3D file of the middle piece, the mid case of this design that's been exported outside of my design program and is ready for printing. So you've got your printer, you've got some models. How do you do the slicing part? We're at we've gotten model, now we're into slice. You're going to do that in a program that is called a slicer. Mostly, you're going to be working with a file format called STL. It is the most common file format for 3D printers. There are others, but 90% of what you're going to work with are going to be STLs. And those are prepared by programs called slicers to print them. The most common slicers are like Simplify 3D, but Cura and Prusa Slicer are the main two. I personally am a Prusa Slicer user. I love Prusa Slicer, and everything, all the examples in this are going to be from Prusa Slicer. All the same things exist in Cura. They might be called different names, but the same processes apply. The software has the same exact goal. It's just whichever one fits you better. So what the slicers do is they cut your file into the different layers, and then they generate all of the what's called tool paths, which is the places that your extruder is going to move to in order to produce each layer of the object. Those instructions are communicated in a format that's called G-code. And then if you look over on the right side background here, this big, giant, multi-thousand line alphanumeric set of instructions, that's G-code. Thank God for slicers, because they literally used to do this by hand, and it was nearly impossible and would make you screw up a lot. Now we just do it right in the slicer. You take this G-code, you feed it into your printer, and your printer translates each of these instructions into a series of movements that make each layer of your shape one at a time. Slicers are really, really important because they have lots of specific tools for 3D printing that's going to make your printers work out. In fact, they have so many settings that it is going to be extremely intimidating the first time you open it up. But thankfully, they've thought of that, and they give us presets. The presets will come with your slicer, and they're built by the creators of each program to work as well as possible out of the box without messing around. You'll have different profiles for different kinds of printers. You'll have different presets for different types of filament. You'll have different presets for different layer heights. And the great thing about the presets is they effectively let you ignore all of these 10 million options that you see over on the right. And they're set up out of the box to be tuned to work well very together. And this is the best place to start when you're exploring these. If you want to change things and see what happens, that's an excellent way to learn. You learn a lot by screwing up in this hobby. It's just sort of how it is. One thing to help you is, at least in Prusa Slicer, you'll notice the dots next to each one of these settings. The settings are broken up into simple, advanced, and expert modes, and you can choose to only show whichever ones that you want, and the others will change based on your settings that you've already made. So you can very easily start with the simple category, which would make this down to about 3 different settings, and then all the other settings that are more advanced will change based on those. So you don't even have to mess around, and Prusa Slicer's profiles get updated a lot. I love them. Some of the things that your slicer will generate are supports, and supports are really, really important because everything is made vertically and nothing can hang in midair. If you look in the upper right, this jackal statue here, the front of the nose is going to be hanging in midair. There's nothing below it. So there needs to be something that it can actually print on top of. Otherwise, it's just going to fail. So your slicer has settings to automatically generate these supports for you so that you don't have to mess around with them. And that usually will make a failure into a success by using supports. However, there are some things to be concerned with on supports. Make sure they don't interfere with functionality. This lower image, we have supports underneath this tube, but also inside. Those supports inside are going to be really difficult to remove. And if something needs to move through that, if there's like a tolerance there, then those might be in the way. So it's not just hit the button, get supports. 99% of the time it is hit the button, get supports, but just take a look and make sure that your functionality or aesthetics aren't interfered with. The other big thing about your slicer is orientation, or how your object is positioned when you print it. You want to make sure that your supports don't interfere with your object. You're only using the supports that are necessary. And you want to make sure that if you're making something functional, that the layers aren't arranged in a way that's going to make it weak. It's really easy to figure this out once you kind of think about it for a bit. And I would recommend starting at that link there, which I believe we dropped in the chat, which is a great way to get yourself started on orientation. This is just a brief primer on some of the effects. In the upper right, this is the same object positioned in 3 different ways. And you'll notice the supports that are generated are drastically different depending on how it's oriented. This will increase your build time for more supports, and it might put supports where you don't want them and make it more difficult. So that's how something as simple as where your object is placed might affect how it works. And on the left, we have a similar example. In the first one, you have to print these supports to hold up these arms of the T. So underneath the arms is going to look kind of weird, and you're also going to have to spend all this time printing the supports. In the second one, you don't have to print the supports, but that side that's on the build plate's a little small, and all the layers are going to be running vertically up this, so this part might be weak to forces perpendicular to it. And then in the third orientation here, there's a nice big surface for it to lay down on, so it'll stick to the plate, and all your layers are going to be organized horizontally across it, so that part's going to be a little bit stronger. So those are the things that orientation can affect. There are also settings for rafts and brims, which is you'll need if the surface area that you're putting on the build plate is really small. Small footprints like to pop off, or they like to warp a little bit, and rafts and brims will fix that. Up on the top here, we have an example of a raft. That is a discrete structure built underneath. And you can see that drastically increases the amount of surface area that's in touch with the plate. And then they've printed their model on top of that. And the plastic will stick to itself a lot better than it'll stick to the build plate. So this kind of mitigates that. A brim is kind of the halfway between nothing and a raft. And that's just a single layer that extends outwards from the edge of your object to give it a little bit more surface area. So this is an example of an object I have sliced up. This is the same object I had in my earlier example. You'll see the green supports are here. And you'll notice up in the upper right, I've just used presets. My layer height is super tiny because I want this to be really detailed. I changed this preset just down a few degrees in temperature because the room my printer lives in is really hot in the summer. And this is a profile that I made based on the stock Ender 6 one for my particular printer. Down below is some more information about it, the size, and then at the bottom, tell me exactly how much filament I'm going to use and then how long my print is going to take. So all of that put together, this is what your workflow is going to be in general. You're going to get your STL from Patron. You're going to figure out what it is. You're going to throw it into your slicer of choice, and you're going to set your settings based on the model and your filament to make it work. You're going to convert that into G-code by pressing a button, and then that's going to export a text file with an extension of .g-code. You're going to put that G-code into your printer somehow. It's usually on an SD card. And then you're going to turn your printer on. You're going to make sure your bed is clean. You're going to preheat it. You're going to level it. And then you're going to choose to print from your card. And you select that resulting G-code file. You tell it to print. And then you're going to stick around for a few minutes and make sure that everything is working out well. If your first layer goes down well, then everything is usually good after that. And then the most important step after you've checked first layer has gone down well, leave it alone. Prints can take absolutely forever, and time stops when you're waiting for them. So just go away and do something else until it finishes. Once it's completed, let it cool a bit, and then you'll remove your item from your build plate. And that's how everything goes if everything goes well. But it won't all the time. Things will break. So I'm going to cover, we're running a little long today, but I'm going to cover the common failures and then how you can fix them. But just as an aside before that, sometimes prints will fail because the G-code is wrong. And that generally happens because you got the G-code from somebody else. In a library context, I am begging you, please never accept raw G-code from patrons. They do not know what your printer is and how it works. And all the settings are put in G-code. And also it's really hard to tell what something is when they just give you a set of alphanumeric instructions. They could be printing something that you can't print in your library. Please be aware of that. Build it into your policies. Never take G-code, only accept raw STL, the actual model from a patron. So we're going to go through each of these general failures in turn and give you some strategies on fixing them. Most common thing you'll see is you'll have low bed adhesion. Your stuff won't stick. And the corner will pop up. The whole thing will pop off. It'll start moving around. And that happens sometimes because you're printing too far away and it's solidifying above the build plate and never sticking. So maybe you want to lower your nozzle a little bit. Sometimes it won't stick and you need an agent on there to get it to stick. You can use glue sticks or hairspray. And those are really common for using some more advanced materials. PLA is usually super nice and doesn't do this. But if it does, the most common fix for PLA is your bed is too cold. It's not sticking as well as it needs to. So up your bed temperature by 5 degrees. And then make sure that the surface that you're printing on is compatible with the material. Some materials really hate different surfaces. PLA sticks to everything. So if you're just using the PLA, ignore that one. And sometimes it's just the parts are physically too small and they're starting to pop off. That's when you're going to use a raft and brim to fix that guy. You might notice failures on your overhangs. So the parts that are trying to print in midair will look terrible. Like I said, no part of your print can hang in midair without a support. You can usually do up to about a 45-degree angle, but any more than that, and it's going to start to fail, and the filament's not going to stick. It's going to look like this. If you've got a print that looks like this, you probably just didn't turn on supports. I do that all the time. You forget. Some models need them, some don't. You may not reflexively hit the button, and you realize an hour into the print when the first one has failed. There are also different types of supports. There's ones that are almost like trees or fingers that are really, really cool. And they'll help print objects like this, where if you have a big brick of supports in here, it might not work very well. The other problem that everybody sees is spaghetti. And spaghetti is what happens when you try to print on top of something that isn't there. This is usually because either a part of your print moved, it popped off the bed and moved somewhere, or you didn't have supports where you needed them and something didn't work. There's really no way to fix this. It just happens to everybody. If you're watching your print closely, some printers have webcams on them. You can usually see it happening and stop it. But if you're running a print overnight unattended and it fails, that's the learning curve. Everybody's gotten the spaghetti. I've got spaghetti dozens of times. It's just how it goes. But if you have really, really, really bad luck, sometimes spaghetti will glom onto itself and it'll become what we call the blob. The blob is melted plastic that has just jammed itself around your nozzle. Sometimes it's a really easy fix. You can just heat it up and pull it off. Sometimes it worms its way around your extruder and will totally destroy your hot end. That's relatively rare, and most of the time it will just stick to your nozzle. The solution for the blob is heat it up and then pull it off, except pull it off with tweezers. Do not use your hands. I have scars on my hands from pulling stuff off of hot nozzles. You don't want to do that. It hurts and it's really dumb. There's no reason for it. Use pliers, use tweezers to get these off and you'll be fine. The other failures that you'll see are pretty much hardware related. Sometimes stuff breaks. Sometimes your cat sleeps on your printer's bed and it makes it not level every single time. Sometimes your printers fell off the table for some reason. Sometimes a cord is in the wrong place and then everything's ruined. These will happen, but they're really, 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 really rare. And I want to tell people on this call, if your printer physically breaks, call me. I love fixing hardware. And I will come out and give you a hand with your printer if something has physically broken on it. For anybody who's on this call, get at me. I really like solving hardware problems. And it's something that can be incredibly frustrating to do unless you have somebody else there to bounce ideas off of. Feel free to use me if that person. So those are the basics for printing. But there are some really cool things that you can do with them. And I'm going to run through these quickly. These are some of the materials that you guys can print. If you get really into it, you can make things from functional gears for RC cars, anything like that. You can make impact-resistant plastic. I'm looking at every computer peripheral I have here is cased in ABS plastic. You could print your own. Just a warning, it smells really bad. Do it at night. You can use things like polycarbonate, which is insanely strong. I use a lot of that in my watch cases. And you can use blended filaments that have carbon fiber in them. Those will destroy your nozzle. You'll need some special stuff for them. Or you can even print really squishy, flexible plastics for making like watch cases and phone straps and things. Those are pretty hard to print as well. But that's when you get into those mods and parts at the bottom. These are all pieces that can be bolted onto any existing 3D printer so that you can use some of these more advanced things. I'm hopeful that you guys will get further enough into the hobby that you want to start exploring this stuff, because this is really where my heart lies in this. I love using crazy and difficult materials and making them work and solving all of the challenges involved with that. And so you may have seen that there are other printers. You've probably seen these guys out there. These are resin printers. They exist. They do some things really, really well. We're really not talking about them in this because they don't work in library contexts. First off, they need extra equipment. And second off, they smell really, really, really bad. And third off, the resin is toxic. And you don't want toxic resin in a public building. This is great for making really high detailed small things. But if you're deciding between a resin or an SLA printer and the FDMs we've been talking about, buy an FDM. Guaranteed it is the best decision. There's also some really, really cool technologies that are out there that are coming down the pipeline. One of them is selective laser sintering, which can make parts out of plastic or metal by fusing layers of powdered material together with a laser. It is crazy, and it produces awesome materials. This is all industrial now, but this is used in advanced manufacturing right now. Lots of dental labs, lots of machine shops are using these processes to produce things, and they operate on the exact same model slice print principle as everything we've talked about here. There's also multi-jet fusion, which is like a gigantic super inkjet printer. That's only an HP thing. It costs an absolute fortune, and you have to have a special processing oven. But these are the sorts of things that are out there that are being used in industry right now that work in the exact same manner as the FDMs that we've talked about here. You can use those same exact skills to move them over. So that has been a fire hose of information. We are finally coming towards the end. If you need any references, any resources, I've collected everything that I've mentioned in this slide deck here. And then I also want to refer you to some of these other options in there. Reddit has an awesome 3D printing community. I have learned a lot there. I contribute a lot there. If you come in and start asking questions, especially if you use the words printer and library, odds are I'm going to end up answering your question. Because I'm a nerd like that. I recommend getting involved with the community. You don't have to post, you can just lurk, but there is so much information out there, and it's a fantastic group of people. We have our own silly memes and silly things that we print that make us laugh. It's a great place to be. All 3DP, there's a couple resources that I've linked that are on All 3DP. They're a great place for setup ideas, modification ideas, general information. They've recently chosen to go super ad supported, which is unfortunate, but put an ad blocker on. It's 2023. You should be blocking most ads anyways. There's tons of resources there. There's also tons of resources in the Prusa forums. Those are predominantly Prusa users, but everything is applicable to everybody, and they really like helping out. And enthusiast communities are a great place to go. Everything else on here is links that have been dropped in the chat and put on the slide deck. So this is just kind of a resource. So if you want to go later to one place that's got links to everything, pop this out. You guys will be getting these slides along with the video when we get around to that. And then finally, go forth, print. There is no way to do this but to do it. It's the standard maker process. Make, fail, make, fail, make, fail, make. And then finally, you will have gotten it. The best teacher is always experience. Get your printer, print out a bunch of benchies, fiddle with your slicer settings, mess something up, and then figure out what went wrong. I want to remind you guys, I keep harping on this community deal. If things get weird, and they're gonna, because this is a really involved, in-depth process we're doing, get in touch with me. Call a colleague. Call somebody who's on this call that you know. The part of the goal here is to put together a group of people in libraries who are interested in and know about the technology that are in our makerspaces, and try to get a place where we can all share our expertise with other people in the field. Everybody in the community is super into helping people out. That's how we learned, and that's how we want to teach others. Get involved with the communities online, make your own communities here. Reach out to me if you are at all interested in these things and you want to continue doing them. Come to my other webinars, and I would love to include you guys in those groups of people that have specific skills that can help out everybody in the Western New York, Buffalo, New York library community. So sally forth, solve some problems, and make some things. That is all that I have. I want to pause briefly for questions if we have any. Um, do
Yeah, thank you, Jay, for such an interesting and very practical presentation. Makes me want to pull up a file and start printing something right now. We do have one question that came through. Is there a perfect environment to have your 3D printer, such as an enclosed room or an open space? Do you want it warmer or cooler? Does it stink at all?
um, Great question. The physical location of your printer can matter a lot, but the most important thing is consistency. You can adjust your temperatures, and you can adjust your prints to compensate for a hotter or colder environment. But what's really hard is compensating for an environment that changes all the time. Um, Earlier, I mentioned that I have a profile set up for my printer at home that is specifically for the summer, because I've noticed that a 10-degree difference in my printing room will lead to a difference in my prints. Most libraries are pretty consistent. And so you can get your print working well in the space it's in. One thing to watch out for is vents. If you have overhead vents that blow air, air currents can wreck your prints. I know this has been a problem at other libraries where they've put their printer in a place and then not realize that at midnight, the air kicks in and they're blasting out air from a vent that's directly over your printer. And all of a sudden, your printer is operating in an environment that's 10 degrees cooler than it thinks it is with air moving around everywhere. That's the biggest thing to look out for, is making sure that your climate control isn't affecting your prints. But overall, I would say an enclosed space might not be the best for FDM, because it will cause more heat to build up. If you can have it more open, you can also show it off to people more. And the prints, they don't have an odor per se, for at least for PLA. Some other materials do. ABS, anything with a styrene in it smells awful, but you're not going to be using those. The PLAs, you can smell that there is heated metal, but it does not produce fumes. Other printers do. That's one of the reasons I recommend FDMs heavily. Don't really smell, and you'll notice the ambiance of a printer, and you'll get to like it really quickly. I hope that answers that.
Great, thank you. Does anyone else have any other questions at this time? If not, you can always reach out to Jay at a later time.
Yeah, definitely get in touch with me if you have any interest. Oh, looks like we got another question in here. Cool. Are they noisy? They can be. Usually the most loud sound you'll hear will be a whir from a fan. It'll be pretty low, but it can be noticeable. Sometimes you'll hear like a little kind of electronic noise from the motors that are driving it, but they make noise, but they are not noisy. It's usually, you can tell that they're on. Often I can't tell when my Prusa is running a room away from me. When it's in my office, I can tell. When it's a room away, I have to walk within 5 feet of it to even like tell whether the fans are running. So they are pretty quiet. And there's things you can do to make them quieter if you want to get really, really nerdy about something, or it's just being unduly loud for some reason. All right, if we don't have any more questions, there is one thing I would like to ask you guys really quickly before we leave here. As I mentioned, I want to do other series that help people utilize the technology that exists in their makerspaces. I have another Padlet. If you could kindly fill this one out that just got dropped in the chat. What other materials and things do you have in your library's makerspace? And what other trainings on equipment or processes would be helpful for you in your library, in your context? I would like a chance to build it based on your feedback, and then hopefully have things that are directly related to the tech that you guys have in your spaces and how to use them better. Give you guys a little bit of time to pop us some information in there. Let's see. All right. You see one coming up here of AR and VR. Awesome. We are definitely going to cover that. I'm really glad to hear that. Cool. I have new ideas. Oh. Okay. Ooh, looks like you guys have some cool tech out there. A mug press. That's interesting. I don't know if I've heard of that. I'm gonna have to look into that right after this call.
I have seen them, at least the ones made by Cricut. They're a lot of fun.
Cool. All right. Well, awesome. Then I get to play with something new. I love an excuse to do that. Um, So thank you guys so much for being here. I know we're getting really close to time, so I'm going to wrap it up. If you guys want to drop some more information in these Padlets, the links are still there. They'll be up for a little bit. Thank you so much for your attendance today. Stay tuned for more Makerspace programs in the future, and let's build an awesome community together. Let me see the stuff you guys print. I'm always looking forward to it, and thanks a lot for being here.
Thank you, Jay. And I just dropped another link in the chat for a survey. It's more general, just an evaluation of this program. If you have a moment, we'd really appreciate it if you would fill it out. I'm going to stop recording and thank you for the feedback, and I'll end the call.